दिल खुल जाएगा। ब्लैक पैंथर पे चला देना।
Good evening, ma'am. May we start?
Yes, please.
Hello and welcome back, everyone. As we continue with the faculty development program, I am delighted to be the host. My name is Ashika, and it is my great pleasure to introduce our distinguished speaker for this session, Dr. Navneet Kaur. Dr. Navneet Kaur is an accomplished academic currently serving as an assistant professor at Chitkara University in Himachal Pradesh, India. She holds a PhD in electronics and communication engineering from the Thapar Institute of Engineering and Technology, which she completed in 2022. With a strong foundation in her field, Dr. Kaur has developed a rich experience in teaching and research, focusing primarily on image processing, digital forensics, and machine learning.
Yes, ma'am, you can start.
Yes, sir. I'm sharing my screen. Thank you for the introduction, Ishika. Am I audible?
Yes, ma'am.
So, as introduced, we are introducing the session on deep learning and image forensics. So, starting with the introduction, first of all, I would like to know from the audience that what is the benefit of digital images in our life? Anyone from you? Okay, so continuing, like we know that digital images that are used in every field of our daily life in digital computing, these are the primary means of the communication. So images, they are used in various fields such as medical. We use these scanned images for any detection of any disease. Then in education, images are used by the professors, by the teachers. Then for animation creation, website designing, in newspaper industry it is very well used in court evidence to represent different kind of evidence of the criminals. So in contemporary times, images that are exposed to heavy manipulation and editing with the help of various image editing softwares. So there are various people and software which edit the images with the help of Adobe Photoshop, GIMP, Picasa, etc. So that is why our topic, first of all, what is image processing?
Ma'am, please share the screen.
Uh, okay, sir. So it is visible. Abhishek sir, at this screen is visible.
Yes, 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 visible.
Yes, ma'am.
Okay. So first of all, what is image processing? Basically, like we implement various operations on the images to enhance the image or to extract the useful information. So that is why it is a type of signal processing in which image is input as an image and output can be in the form of any image or features that are associated with it. So we perform different features, different feature extraction methods, different feature selection methods on the images to get the fruitful results. So before starting going to What is image forensics? First of all, we should know that what is forensics, what is digital forensics, what is analog forensics. So starting with what is forensics? Anyone who knows that what is forensics? Anyone from audience? Okay.
Identifying,
Yes,
madam,
sir.
good morning. Identifying important information from the investigation purpose.
Okay, sir. Yes, basically, the forensics as the use of science and technology so that we can investigate the crimes, because what happens that many people, they create the fake images and put it on the social media, so they can create the fake images, or they are creating the fake evidence that are represented in courts. So that is why to detect the forensic, it is very important nowadays. So forensics, that is divided into two main parts. First is analog forensics, then second is digital forensics. So coming to analog forensics, basically as we see various web series or in real life, like in case of any crime, in case of any murder, the police officers or forensic department, they detect the fingerprints and DNA tests. So analog forensics is the, it comes under that, DNA test and fingerprints come under analog forensics. So it focuses on finding the real and physical evidence that is solid and trustworthy. For example, like fingerprints, I have already discussed, and it cannot be manipulated. So analog forensics cannot be manipulated. But on the other hand, digital forensics are those that deals with electronic devices, like we are using pieces, the laptops, mobile phones that are used in daily life. So digital forensics, that is created by these electronic devices. So further, the electronic devices that are divided into two parts. First one is computer forensics and second is multimedia forensics. So, what is the difference between computer forensics and multimedia forensics? We are coming on that slide. Basically, computer forensics is that, like, if we take any evidence from the computer in that is used in illegal activities, so the data, for example, any coder that hack any code, okay, that comes under computer forensics. Experts, they can gather the data from the computer and it can represent as an evidence that this code has been corrupted. On the other hand, multimedia forensics is that involves the digital files, for example, your images, your audios, or your videos. So our main motive in forensics is to check whether these files, either image, audio, or video, that are tampered. Tampered means, I think everybody should be aware of this term. Tampered means forged images, or images, videos, or fake images that will ensure that either they are authentic or not. So further, the multimedia forensics, it is divided into three types. First one is image forensics. If I may know that anybody has the knowledge of what is the image forensics or video or audio. You can type your answers in chat box as well. Okay, so coming on image forensics, basically what is image forensics? That like we know that many fake images that are created by most of the people, and it is put on the social media. So the image, the purpose of image forensics is to identify those fake or altered digital images so that it can ensure that whether it is authentic or forged. So it deals with checking if the picture is really fake or really authentic, and it helps to provide a clear answer that whether the image has come from and whether it is valid or not. But on the other hand, many fake videos are also uploaded on the social networking sites. So video forensics, it is used to detect if the videos have been tampered with or edited. So it can be used for various fake or illegal activities. Fake videos can be used. So it is very important in fighting the crimes that to note that whether the videos are either they are genuine or fake. On the other side, the third type of multimedia forensics is audio forensics. Sometimes what happen that in any illegal activities, the audio is being tampered by various people. So audio forensics is process of collecting and examining as well as analyzing those sound recordings. So these audio files, they can be used as an evidence in the court or an investigation, so that it can it is related to corruption, accidents, or any legal activities. So there is another term that is known as digital image forgery. These two terms are very different. Forensics means to detect the either the image, video, or audio is fake or not. On the other side, image forgery is a different type of term. So basically, image forgery, it is like many images, digital images that are being edited for various malicious purposes. That fake image that is being created, it is known as forged image. And the process of creating that fake image, that is known as digital image forgery. So what happens that these images, the fake images are created, it can contain misinformation, it can be a very serious, it can be such that these posts, they can change the people's perception, that they can lead to social disturbances. So it is very important that image forensics came into existence, and it is very big challenge that image forgery should be detected by image forensics department. So there are various techniques that are used for identifying the image forgery in existence. We will go back to those techniques. Before discussing these techniques, we will first of all look at the historical viewpoint of image forgery. So, creating the fake images, it is not new. It was started in early 1800s. So there was one of the first Hippolyte Bayard. He created his first fake image in 1840s. Okay, in this image, he was acting, or he has created an image of committing suicide. So there are various examples from the past in which fake images has been created in 1800s. So one of example I will show in the diagram, that in 1865 there was a General Sherman, as shown in the left side of the image. He was seen posing with his other members. Actually what happens that at the right side, that is the original image. In original image he was not present, his image was incorporated in this original image, and it was created a fake image. Similarly, in 1936, Mao Zedong depicted in the very far right, and thus the left side of the image, it is forged image, and right side is the authentic image. What happens that Mao, he was removed, Poco was removed from the original image because he fell out of favor with Mao. So that is why the person shown in the red marked area, that is being removed from the original image. In this way, the historical viewpoint, various images were created in the history. The recent incident took place in 2011, when a photograph was uploaded on the Twitter of Iranian president shaking hand with US President Barack Obama. But this photo in the shown in the left side, it was fake created. Original photo was of Indian Prime Minister Manmohan Singh, and he was shaking hand with US President Barack Obama. So the fact of image tampering is that more than 50% of the images on social media, they are edited. So deep learning techniques, they help to unmask those alterations, ensuring that we can see the what is the real picture. So various technique has came into existence so that we can detect most of the images that are being uploaded as authentic or forged. So the main topic is that image forgery detection. Basically, what happens that image forgery, now I hope that everybody must be known to the term image forgery and image forensics. So it is divided into two types. Basically, it is of active techniques and passive techniques. So what happens that firstly we have seen the digital watermarking, we have seen the digital signatures that is embedded on your documents, on your images, but there is some disadvantage of active techniques due to which the passive techniques came into existence. So what happens that we know that their digital signatures and digital watermarks, they were incorporating special features or information during the creation of image. So this requires human intervention. Due to this, to avoid the human intervention, passive techniques came into the existence. These were of five types: pixel based, format based, camera based, physics, and geometry based. So, our main topic of today is copy move, forgery, and splicing forgery. We will focus on pixel based passive techniques. So, first of all, what is copy move forgery? Uh, First, I'll show some example of copy move forgery. Like this is a picture at the left hand side. In left hand side, we see that there is only one pillar in the image, and on the right side there are two pillars. So what happens that in copy move forgery, it is a simple type of forgery. In this, a portion of image, it is copied and it is placed into the another portion within the same image. As we have seen in this image, this pillar, it is copied and it is being pasted to the within the same image to some another place. And this way, copy move forgery is being created. So basically, it is of two types. First one is single copy move forgery, and second is multiple copy move forgery. So the difference between single copy move and multiple copy move forgery is that in single forgery, only one single piece is copied and pasted into the same image. But in multiple copy move forgery, these some portion that is shown in yellow box, it is copied and it is pasted at multiple locations within the same image. So as we can see that red boxes indicate the fake portion and yellow portion represents the original authentic portion. So I hope that copy move forgery is clear. So coming to next topic, that is there are two types of, basically three types we can say, to detect the copy move forgery. Basically, we can copy move forgery is just copying the one portion or more than one portion and pasting it into the multiple locations or single locations. So it can be detected by three ways. First one is block based. As the name indicate, block based techniques, what happen in block based copy move forgery is that, as we can see in this image, there are two leaves that is present. Basically, it is an example of an forged image that is created. So in block based, what happens that first of all, the images that are divided into blocks. So we can divide the image on to any block, that is 3 cross 3, 5 cross 3, using various feature extraction techniques. We can use various transforms to divide the image into different blocks. Then what happens that these blocks, these are being analyzed to find the identical portion. So after that, we apply feature matching techniques. For example, k nearest neighbors can be used. Another feature matching technique can be used. In matching, what happens that if, for example, this block, it is being copied, one leaf that is down, it is being copied to the another location. So these two boxes, they match with one another, and we are able to find out that this is the fake image. So if the matching blocks that are found, we can easily detect that duplicated image is being created or it is genuine image. On the other side, the second type of copy move forgery, that is key point based forgery. So before starting with key point based, some brief introduction that there are various type of block based techniques that we can use to detect the forgery. Like we can use DCT, discrete cosine transform, PCA can be used, various wavelet transforms, Fourier transforms can be used, the Nike movements can be used. So these are used to extract the features. And similarly, we can use different techniques for feature matching to find out the genuine and fake image. Then coming to key point based technique, basically key point based technique, it is a type of image tampering in which we focus on identifying the unique features. In block based, we were dividing the image into different blocks, but in this, we will extract the various features from an image. For example, it can be corners, edges, any features by applying various feature extraction methods. And when the image is divided, we when the features, various features are being duplicated. For example, if in same example we will take, like in this leaf, when we extract the features, these features of first leaf and second leaf, they match with one another, and we are able to find out that this image is being created by it is forged image. So there are various different methods to detect the copy move forgery. Like we can use scale invariant feature transform, we can use speeded up robust features, ORB, that is oriented fast and rotated brief, can be used. We can use a shift method, then we can use brisk method, that is binary robust invariant scalable key points. We can use a case and accelerated case, that is a case. So various different techniques are present, with the help of which we can detect the key point based copy move forgery. So third type was hybrid forgery. So what happens that in block based forgery, it is better to perform when we go on smooth areas. It provides robust results when we apply on JPG compressed images, but it is more time demanding. But on the other hand, the key point based, it perform well when we use the images that have gone under geometrical attacks like rotations, scalings, but it has low computational time. So there are advantages and disadvantages of both the techniques. That is why hybrid technique that came into existence, that uh, uses the good features of block based and key point based techniques, and it performs better in comparison to both the techniques. Then I'll show one example from one of my research paper, that in this what I have used, that I have taken one input images which contains a data set of authentic as well as forged images. Then I've applied color conversion. Basically, I have applied different color channels, that is HSV, RGB, and YCBCR. According to my simulations result, I have attained the results in which CR channel performs better in comparison to other techniques. After extracting this table, then I have extracted the features using adaptive over segmentation, that is slicer method, and different techniques, that is I have merged two techniques, that is shift and AKs was used to extract the features after this. So I have in this adaptive over segmentation is basically the block based technique, and shift and AKs is the key point based technique. So I have merged both the techniques and apply a SVM classifier that will classify the images into authentic and forged. So in this case, in the second row, I have applied further feature matching on the forged image. After applying feature matching, we can see that there is a detected area that at which detect the authentic part that is being copied and the forged portion that is being pasted within the same image. So these were my results, that I have applied different techniques, and in this the combination of all the three techniques were better in comparison to other combinations on different various data sets. So next, this was the result in which in the same paper I have detected the single and copy move forgery. So we can see that the first row represents the authentic and second row represents the forged images. The ground truth was already present in the data set, and these were the detection results. And this I have evaluated performance parameters like precision, recall, and f1 score by comparing the ground truth as well as the detected results of my technique. Similarly, I have worked on multiple copy move forgery, in which you can see that in ground truth that one portion that is pasted multiple times, and the results in terms of precision, recall, and f1 score has been computed. So these were the results of copy move forgery. Next term that is we have seen in the flow diagram, that is image splicing forgery. So till date how I have covered the copy move forgery. Anybody have any doubt? They can ask in the chat box. Okay, so coming to image forgery. So the difference between copy move forgery and the image splicing forgery is that in copy move we have seen that one portion of the image it is copied and it is being pasted within the same image. But image splicing is somewhat different. In this, we are combining two or more images to create a fake image. So how it is created is that, for example, we are saying at the left side we have two images. These two are authentic images. One is showing the scenery and one is showing the bird. So spliced image is created by merging both the images. So basically image splicing is a technique of combining two or more images, and in this specific section from one image and is being placed into the different image to create a fake image. So next is deep learning image forensics. I hope all these sessions were related to deep learning and everybody must be clear about different architectures of deep learning. Okay, sir. Prabhu sir is asking which area it is applied. Sir, sorry, it is. I'm not able to understand. You're asking about which area? So basically, copy move forgery, it is applied if you want to detect the fake images, fake videos. The copy move forgery and image splicing, these are the types of image forgery. So as I have shown in the starting diagram, uh, see, image forgery, it is divided into passive forgery and further the passive forgery. In this copy move forgery and splicing, they are the part of pixel based techniques. So we have used the copy move and splicing to detect the image forgery detection. So next, deep learning techniques. So before starting deep learning, I want to ask one question, that can anyone explain the importance of image forensics in context to digital media?
Fake video identification.
Okay, sir. Anybody else? Uh, Prabhu sir, on video tomorrow, Dr. Abhishek will take the session. So I will be covering image forensics and he will be covering video forensics. So deep learning, basically, as we know that nowadays deep learning it is being significantly used in each and every field So, in similarly in image forensics, it is being significantly advanced. We can apply different architectures to detect the image forgery. There are different architectures, all are known to various standard CNNs, AlexNet, VGGNet, RSNet, and UNet, EffectiveNet. So this is one of the example that is being used to detect copy move forgery in digital images. So this proposed algorithm, it tells that if we are taking a data set, input image contains a data set of both containing authentic as well as forged images. After that, pre-processing is done by resizing the images, and Clahe is used to enhance the texture of images. After that, CNN model is being applied using various convolutional layers, max pooling layers. So, like this, similarly, we can use different architectures to detect the digital images. We can perform segmentations using CNN. We can detect whether this, we can provide assemble learning algorithm in which we can merge different architectures of CNN and prove that which CNN performs better in comparison to other techniques. So there are various image forgery data sets that are being available. If anybody wants to work in this field, there are various data sets like grip data set, IMD. In each of the data set, we have seen, or we are being seen, that authentic images that are given in the first row, and in the second row there are being forged images that are depicted in the red part. So these all data sets, they are available online. Anybody can download and work on the any of the data set. These are freely available. So we can work on like grayscale data sets like DVMS, rest all our RGB data sets. These are the description of various image forgery data sets. Like first, that is image manipulation data set, which consists of total 96 images, in which 48 are each of authentic and forged, and the format is PNG. Similarly, we have contain F220, which contains 220 images, then F2000, which contains 1300 authentic images and 700 forged images. And all the data set contains different number of images, different types of images, and it also contains different resolution of each and every image. So using different software like MATLAB, Python, we can in fact change the resolution. We can resize the images according to our configuration of a laptop. Like we need 50 cross 50 images, we can use image resizing technique, which I will show in the practical session using MATLAB. So basically, next title is framework of image forgery detection. So, what are the main criteria to perform forgery detection? First of all, it is very obvious that we need a standard data set, benchmark data set, or we can create a data set by its own if we have high definition camera. Then preparation of data, like we can use various pre-processing techniques. We can use different filters, standard deviation filter, Gaussian filter. We can use Clahe, that is contrast limited adaptive histogram equalization. We can use the image resizing so that our processing can take less time in comparison to other models. After that comes feature selection and feature extraction. This is the very important box. In this, we can use different techniques that I have discussed earlier. Like we can use shift algorithm, we can use AK's algorithm, we can use ORB, various discrete transforms that are used to extract the features from various images. After feature selection and extraction, then there is one important term, that is classifier selection. If we are working on machine learning, we can use different classifiers, SVM, KNN, random forest. And if we are going on deep learning techniques, then we here need to classify which architecture of CNN we are being used. Then last is performance evaluation. The main performance evaluation that are being used in this forgery detection is like accuracy, precision, recall, that I will discuss later on. So after the evaluation these performance parameters, we are able to compute either the proposed technique is better in comparison to other techniques or not. So it is one of the important uh, parameter in the framework of image forgery detection. Then there are various information sources from which we can collect the data related to image forgery. Everybody is known to IEEE, Springer, elsewhere. It can be Wiley, then ACM, Google Scholar, Semantic Scholar, Taylor and Francis. So from these various websites, we can collect the research paper. We can get to know that what other peoples are using and what we can think about the novel techniques we can apply to our algorithm. Then I have added some useful list for detecting the image forgery. So first of all, there are some journals and mention of Springer and elsewhere. If anybody is interested in working in this field, they can search these journals and they can search different research papers from these journals. Like in Springer, multimedia tools and applications contains number of research papers, pattern analysis, neural computing and application, and machine vision. Similarly, on elsewhere site, there is computer and electrical engineering, forensic science international, then signal processing, forensic images, image and vision computing, information science, pattern recognition. Next, there are some journals in IEEE and Taylor and Francis, like IEEE transaction of on image processing, IEEE transaction on information forensics and security, and on the other side, Taylor and Francis, like Australian Journal, International Journal of Electronics, IETE. And last is some journals of Wiley, like IIT Image Processing, Security and Communication Networks, International Journal of Intelligent Systems, and some other journals like Applied Sciences, Turkish Journal of Electrical Engineering. So these were the some useful list of detecting in who are in the research of image forgery detection. They can go through these different journals and select the research paper according to their area. So last as performance evaluation criteria, everybody is known to confusion matrix, I hope. Can anybody tell that what is confusion matrix? So basically, confusion matrix, it is a two-dimensional matrix which consists of different parameters, that is true positive, false negative, and true negative. So what is the meaning of true positive in terms of image forgery is that if, for example, this positive represents your authentic image and negative means the fake image. So if your originally the image is authentic and the detection represents the authentic image, it is represented by true positive. On the other hand side, true negative is if originally the image is forged and your proposed method it detects the image as false, that is known as true negative. Then coming to false positive is that when originally your image is authentic, but a model is detecting the fake image. So it represents the false positive. And next is false negative, in which the our image is actually fake image and model is detecting it as authentic. So these are different parameters. These parameters play an important role in calculating different performance parameters like precision, recall, accuracy, F1 score. Next, if anybody has any query related to this, you may ask. Okay, so we will continue with practical work. If anybody has, in fact, any doubt in this topics, they can type the question in the chat box, and I will be back in 2 minutes. Okay, so ma'am is asking that how we can increase our image dataset size. Actually, ma'am, in like image forgery dataset, there are various geometrical attacks. Like if you search image forgery data set. There are attacks like rotation, scaling, JPEG compression. We can include those attacks. Moreover, there are different methods to increase the data sets. Like we can enhance, provide the color variations. We can use like you have one data set. For example, your first technique is to provide the geometrical transformations like rotation, scaling, flipping, and you can detect the forgery. Second, you can add noise and you can detect this. Then you can apply various image sharpening techniques. In this way, you can create a mixture of different various data sets. I hope it is clear, ma'am. Okay. Anybody else? Okay, so coming to practical session, I'm just sharing my screen. Uh, okay, are there any methods to detect forgery if it is highly compressed? Like we can apply JPEG compression, like double compression techniques. We can apply error level analysis and various other techniques if our images are really compressed. These methods are can be applied to detect those images. Abhishek sir, give me just 2 minutes. I'm opening MATLAB.
Okay, ma'am, no issue.
Sir, is my window visible?
Yes, ma'am, visible.
Okay, fine. So, I'll start with some introduction with MATLAB. I hope most of the people are known to the MATLAB platform. Basically, it is very similar to Python programming. First of all, we can create like the folder, like we will go on plus sign and then we can save by using any name like code FTP. Then the left hand side it shows the workspace, like if we are typing any code, for example a is equal to 1, b is equal to 2, and we are running this code, the variables value are shown in the workspace, and command window shows the different algorithms that we will run on this editor window. So today I will first of all show that how we can image the resizing can be done using the apps in the MATLAB that is being already installed. So first of all, we will go. There are on the top of the MATLAB window. There is home, plots, apps. These different apps are available already in the MATLAB. So there are various platforms which are being required, and you can only install those platforms. Like I'm using image processing platform, signal processing. There are various other platforms according to your need. So in this we will go on image batch processing. So it will take some time to open this. So before running the image resizing, first of all, we need to create a function of image resizing. We will start with function. Then let's say there is a variable that is known as result. Then we will create a function that is my IM function into IM. IM represents the name of an image. Then we will go on same variable that is results, that is equal to IM resize bracket IM, and we will take the dimensions of the image in which we are going to resize. For example, we need the images into 50 cross 50. We will put here 50 cross 50, and we will save using my IM function in the folder. After that, we will go back to the image batch processor window, and thus our first task is to select the function name that we have already created just now. We will go on the folder in the MATLAB window, and here we have created this function. We will select this function, and then there is one option of load images.
Ma'am, mm,
Yes, sir.
another window is not showing. Please share with complete screen.
Okay, sir, fine. Sir, it is visible now.
Yes, ma'am, visible.
Okay. So again, like I will start. I think I hope this window has been visible. We have created the function, then we have gone on apps, and then we have selected image batch processor. We have obtained this window. From this window, here is function name. We will go on the folder, and we will select the my IM function that we have created recently, and we will go on open. The folder, the function name has been selected. Now our next task is to select the folder of the images that requires resizing. Basically, in this image batch processor, it is very useful because there is no need to do resizing of one by one images. We can select a folder and it will resize the whole the folder at once. So we will go on load images, we will select this, then we will browse which folder we need to resize. So I have put some my few images in this. I will show the images. Like I have put some 16 images. First of all, we will check the size of these images which we are going to resize. So going to check this size, images of 1024 cross 768 image, and I hope all the images are of same size. Properties, then detail. Yes, all are images of same size. Then our main purpose is to select this whole folder which contains the images. We will select the folder from this directory, and after that we will load that folder. So it will take some time to load the images in this folder. So all the images has been loaded in image batch processor folder. Now we have included the function name, which will resize the images into 50 cross 50. Then there are two options. First option is process selected and second is process all. Let's say we need to only cross check that we will select one image and we will apply process select and we will export this image. The second method is that we can process all the images simultaneously. We can resize all the images simultaneously. So we will go on process all, and the function has been started. So it is being taken. Like I have selected, I think by mistake I've selected one image. We will see. Then there is one option to export these images. Either we can export all the images into your workspace, into your files, or we can generate another function. So what I am doing is I am exporting these images to one file. So you can create file. First of all, they are asking to choose the file format from image fields. So output is represented in the different formats of the image. You can select any format according which you need to work upon. For example, I am selecting png format, and then we will go on output directory name. That is, we will go on browse, and we will select that where we need to save this code. So we will go on, for example, I am going to select, create a new folder that is resized images. This folder has been created and I will select this folder and okay. So all the 16 images has been exported to that particular folder. So for checking this, I will go back to my folder section. Like we can see that resize images folder has been created and the images has been resized. To verify, similarly, we can again check the size of the images. We will go on detail. See, we have created a function which will resize the images into 50 cross 50, and in this images are being resized to 50 cross 50. We can check any image. This is 50 cross 50, so all the images has been resized. So similarly, we can create or we can perform image resizing on thousands of images simultaneously, which will save our time. It may take some time to process, but it is very easy task. So I hope this is clear to all the audience. Yes, ma'am. Yes, it is compulsory for if you are running convolutional neural network, any architecture. So it is compulsory that all the images should be of same size for better evaluation of that particular model. So closing this folder, then next, we will start. I'm going to apply CNN architecture using MATLAB on the some of the images. First of all, I'll show that I have created some folders, like I'm using grip dataset. I have first of all created different folders of training and testing, and this some images are given to authentic and some images are created into the forged folder. So these folders are important so that we can perform the training and testing part. So first command that is used as in MATLAB is CLC. Basically, CLC, it is used to clear the command window. So we can see that at the bottom of this window, this is the command window. And if I will go on editor and I will run, this whole window is being cleared. Then next, clear all, that is used to clear the workspace of the MATLAB that is given at the left hand side. So all the workspace has been cleared. And close all, is used to close all the figures if it is open. So these three commands are very important. Then my first task is to select the root of the folder. So I will use MATLAB root. So in this root, I will select where are my training data. So this is my folder which contains the training images. I will go on copy and then I will paste this folder here. After that, dataset path. Set path is equal to full file, and we will go on this. So dataset path is used to build the full specifications of the specified folder or file that we are going to work upon. Then next is data, image, data, store, and then we will select the data path. Include subfolders. Then label source. So basically, image data store, it is used to create object that is used for managing the different images that are stored in different folders. So if we are working on multiple folders, this is important. Then we will go on folders name. So after this, we will go on next command, that is count label. And here we will count the total number of count of the data on which we are working. Then we have taken a variable that contains this data. So next is this was to these commands were just to select a folder that we have used for training purpose. Then we will apply CNN. So everybody must be known that our first layer, that is we will used here, that is convolutional layer. So we will go on convolutional first layer and we will use command that is convolutional 2D layer 3 3. These 3 represents the size of convolutional filter. Then 64 represents the number of filter, and then comes the number of channels. And we are working on RGB image, so we will take it as 3. So next, we need to select the stride. So basically, stride we will take as 1 1. Then we can further take a variable that is padding. So stride is basically that the filter, it will move by 1 pixel, and padding will add around the input, like it will add one to horizontal side, vertical side, top and bottom. One pixel will be added. Then we will go on rate, learning rate. And then as rate L2 factor. So we have selected the learning rate factor as 1, and then L2 factor, that is L2 regularization, as 0. Then is bias, learn rate factor 1, and then is bias L2 factor, which we will take its value as 0, and its name will be represented, like we have selected its name as on 1, that is convolutional layer 1. Then we will go on convolutional dot weights. So these are the size of window, and 64 is the number of filters. And we will go on dot bias equal to, we will generate random So this was the different parameters for selecting a particular convolutional network. We have given its name convol 1. So we are taking the 6 to 7 layers of convolutional layer. After convolutional, there is ReLU layer, and then there is cooling layer. So I will go on this, and I will go on convolutional 2. I will take it, it's now channel as it will become 64 because the previous convolutional layer was of 64 size. We will take same value of strides and padding, so its name will be convolutional 2. So then further this convolutional 2, 2, and then this is third convolutional layer. Convolutional this, then we will take like we can increase the number of filters in this layer, that is convolutional layer 3 will contain 128 filters, and previous size of the filter was 64, and we will take it as for example 64. Then the padding will be same, the learning rate will be same, L2 factor will be same, and here we will change the name into convolutional 3, and its value will be 9 into, now its layer is 128, into random numbers, that is 3 into 3, and this has become now 64, and it has become 128, and here we will take 3. So these are the different parameters that are being used. And next convolutional layer, we will take convolutional layer 4. Same. Then last previous number of filters were present, that is 64. We will take here 128. Number of channels here it will be 128, and then stride padding it will be same. Learning rate will be same. We can change the name of this convolutional layer as well. That is convolutional layer 2 square root 9 into 128 because it is of 128 size, and then random numbers here again size is 128, and again here this we have forgot to change that bias, the value of bias will be 128, and this is the size of previous layer. So here we have taken the layer of previous, that is 128, so we will change it into 128, and this is the fourth convolutional layer. Similarly, if we are taking fifth convolutional layer, so this will be the fifth convolutional layer. For example, we need to increase the size of filter, where we will take 256, where number of channels will remain 128, strides can be same, weight factor can be same. So in this way we can define different convolutional layers. Here it will turn to 256. This will turn to 256 as well. I think it will be 128 as well because the size of filter in this layer is 128. So similarly, fifth layer we have taken, we can take the next layer, that is sixth layer. So here 3 cross 3, if you want to keep 256 same, we can keep it, or we can increase the size of filter. Stride will be same. Here we need to change, that is it will be 256. In fact, here it will be 256. So the previous layer filter was 256. So this will be 256. So this is the convolutional layer 6, and then further seventh layer. So this we need to change the sixth layer. The sixth layer. So this will be the seventh layer. This will be the sixth layer. So similarly, we can change, we can declare different convolutional layers. So so I am I have already pasted the code in different folders, so I'm not going to type this. This was just to tell that how we can use the different folders, how we can declare the convolutional layers, and then we can, like here I have done, use different 8 convolutional layers. After that, I have declared the fully connected layer. So 4096 means total number of neurons that we are using. So as we can see that when we were declaring the convolutional layers, we are seeing that the number of filters that is being increased. So I have shown in this, in fact, in my PPT, one of the convolutional layer, like in this diagram, starting of the convolutional layer, here we have taken 50 cross 50, that is 50 cross 50 is the size of image, into 64 means the size of filter, and as we see that we move forward, the size of filter is being doubled. Like two, the size of two convolution layer is 64, the next two is 128. So we can declare the different architectures, like I have used basic CNN, which is a 16 architecture. You can use any architecture from this, and then different fully connected layers has been declared. Then ReLU function has been declared. State of max pooling has been declared. Then, as we do in Python, similarly, the layers represents the sequence of different layers in your architecture. Like starting was my input image, then I have taken first convolutional layer, and as I think everybody should be known to this, that after each convolutional layer there is a ReLU layer. So I've taken one convolutional layer, then ReLU layer, then second convolutional, then ReLU layer, then I've taken max pooling. Then similarly, all the layers are present in one sequence. So this was just the declaration of the proper architecture. After that, what I have done is I have again tracked the roots of the testing folder. Like this folder, I will go, for example, I have taken validation folder, I may take testing folder. So it also contains some authentic images, some forged images. So I have declared the testing folder. After that, the main option variable, it declares the different parameters. Like I have taken sgdm variable, and then I have taken two epochs so that my computational time is in decrease. I'm not going to run the proper code. I'll show my results of the paper. Like I will run only with two epochs. Then I've taken batch size. I hope everybody is clear that what is batch size, what is the impact of epochs and iteration. Anybody? So I will just tell the basics that what is the epoch. So, for example, like I am going to run this code, so we can specify the epoch that it is the one pass to the training data. Like I am taking 1,000 images, so one pass to those 1,000 images, that is known as epoch. And there is when I will run this algorithm, there will be a term that is known as iterations. Basically, iterations is update of the parameters in one epoch. And there is another parameter, that is batch size. So here batch size is very important. Like, I will take one example, that how we can calculate the batch size, number of epochs, number of iterations from the batch size. Let us assume that if you contains your data set contains images of 1,000 images in a one data set, okay, and you are taking the batch size of, let's say, 100. So how iterations are being calculated is, iterations formula is equal to, number of iterations can be calculated by total number of images divided by 100. So it will be equal to 10 iterations per epoch. So 10 iterations will be present in one epoch. So for example, if you're taking here in your model, your epoch is, you're taking 5 epochs, and your images are 1,000 images, and batch size is 100. So you can calculate the total number of iterations, that will be equal to 5 into 10. That is, we have calculated there is 10 iterations per epoch. So there will be total of 50 iterations in your performance model. So similarly, we can calculate, uh, depending upon the batch size, what will be the number of iterations. So I have taken 2 epochs, then I have taken batch size of 32. These all parameters, that is learning rate, I have taken 0.001. So these all parameters need to be changed depending upon your type of data set. For example, my results are coming better with 32 batch size. Maybe your results are coming better with batch size of 16, batch size of 8, batch size of 4, any batch size. Maybe my results come better with 50 epochs. You can try again, simulate your results, and they can be any value. So basically we can say that it is head trial method depending upon the type of data. So after that, what I have done is, this is used to train the data set, and this the data set is being trained. We will get the plots of training as well as loss. So now I will run this algorithm with 2 epochs, so that we should not waste much time on running this code. So add to path, and it will take some time. So training progress window is open. Like we can see, there are two types of graphs. One will show the accuracy graph, and these are the epochs. Like we are running our algorithm on 2 epochs. At the right side, the time is shown. Elapsed time means how much time it will take to compute this algorithm. Then epochs shows the total number of epochs, and iterations per epoch. Like we have calculated, we have taken fewer images, so there will be only 3 iterations per epoch, and maximum there will be 6. So this is just an example that we can plot the different graphs in corresponding to training accuracy, validation accuracy, as well as training loss and validation loss in respect to the different epochs and iterations. So this was how to evaluate the graphs of accuracy and loss. So I'll show one more example, that how we can compute different parameters like precision recall. So here we have calculated, like we have checked that there is training data, there is testing data, and predictor data. So I will take one example. Uh, I have already made one code that is evaluate code that consists of different parameters like we have seen in the slide, that consists the values of TP, TN, FP, FN. So basically these are the formulas, like if your actual code is authentic and your predicted code is authentic, idxe, I have specified a variable that stands for authentic images, and not authentic means these are the forged images, so tn is the calculation. That fp is basically n is the total number of authentic images, so total images minus the tn, it will represent the fp value. Then after that, I have implemented different formulas to calculate accuracy, sensitivity, specificity. Basically, accuracy is the probability or proportion of TP plus TN upon total number of images. So N represents the total images that are present in the data set. And then sensitivity, that is true positive rate, that is equal to TP divided by the P. P means true positive. Similarly, these formulas can be implemented. We have to, first of all, we have to make a function in which actual stands for the actual labels that are original labels of the data set, and predicted are the which the model predict after running the your code. Then you can calculate these parameters, and last you need to specify all the parameters in one free. Yes, anybody? Okay, then how we can calculate these parameters? Like I have already computed, like these were my actual number of labels that I have computed from my data set. One represents my authentic images and two represents my forged images. So like I'll show, like first of all, actual labels I have taken. After that, predicted labels are predicted, which are predicted by my model. I have taken both the values, and then I have applied that function that is evaluate actual into predictor. And when I will, for example, I will run this code, it will represent all the values of those labels. Like we have seen that when we have done the created this function, accuracy means which I have run my code previously, it will show 98.20 accuracy. This is the value of tnr, this is the value of precision recall. So similarly we can calculate different performance parameters after running your code. So this was all about how we can implement. I'll show one of a research paper in which the code has been implemented, and what was the experimental results. Like this is, in this I have used the same algorithm. First I have resized the images, then I have provided the Clahe image that I have explained earlier. After that, after running my code, we have attained the different graphs. Like these were my simulation results. Like I have run total these this was the implementation environment, and these were the results attained from each epoch. Like I've run on 60 epochs for this data set. This was the value of my training accuracy, and it is shown that with the increment of each epoch, the accuracy has been increased. So these values are attained when we run the previous code. And similarly, we can attain these results like accuracy versus iterations, then loss versus iterations on different data sets. So it depends upon the data set that how many epochs are required, what will be the batch size of your uh, proposed algorithm. So I hope that this maybe 1-2% it might be clear that how we can implement cn and how we can compute these performance parameters. So next I will move on again apps window in MATLAB. Firstly, we have done the image resizing. Second, for example, if you want to create mask or segmentation of any image, instead of running the different algorithms, we can again use this app window in MATLAB. Like we will go on app and then we will go on image processing and computer vision window. There are various options, and for example, we need to do image segmenter. We will select image segmenter, so it will take some time. So the window has been open of image segmenter. So what we will do in this window, that here is same option as we have seen in image resizing. That first task is to load an image of whose segmentation or whose mask we need to create. So I will load one of the image from my data set. I will go on folder that is resized images. For example, I will take this image. The image is being loaded in this window. Then if we want to create the mask or binary image of this image, there are 2-3 methods. Like for example, if we select on local graph cut, in this we will select ROI, that is region of interest. We will go on ROI and we will select that particular region. Like here an example is already given that we can select a box for which particular object we need to create ROI, and then we are able to see the binary image. So what we will do is we will select, for example, if we are going to select this particular bird, this we will, blue portion is showing the preview of this. After that, like we have marked the foreground and background. So basically this blue portion, it will show the foreground. If we want to mark the background, we can select this pencil and we can select this item. So this is up to you that how you want to create. You can even erase this portion. So I will again start create ROI region, that is selecting this particular part. Like we have seen that preview, this is shown only this image, the peak of the bird is only shown. So we can create the foreground using this pencil. Like we can in fact create the background that we do not require this particular window. I'm taking just an example. I'm like simultaneously we can check the preview. So simultaneously we can check the binary image of this, like this portion is not shown, so we can apply different. For example, if we don't need to apply, there is another method that we can go on graph cut. We can again mark the foreground region, we can mark the background region, and then after that there are various options that are present in morphological. Like for example, I am again taking, again this just showing an example that we have selected that graph cut, we have seen the binary images, and we are going on apply. Then after applying, we will close the local graph cut, and then these two options and more options are being activated after applying the local graph cut. Then if we want to refine this mask, we can go on morphological window, and there are different options. Like if we need to dilate mask, means which will expand the foreground mask and which can shrink the holes here, foreground holes. Similarly, we can erode the mask, which will shrink the foreground mask and it will expand the foreground hole. So these simultaneously operations can be applied. Like dilate mask, it is very less visible, but there is some difference. Like here we can see that when we have applied, erode mask will shrink that portion. Similarly, open mask, it will little bit erosion, it will remove the foreground objects which are smaller. Then we can close the mask. So according to your function, you can apply, we can select different shapes of the mask like what we need, and you can simultaneously check the binary options as well, and then you can go on apply. So in this way, we can create a mask of an image. If anybody want to apply on data set, like I have shown the forgery data sets, like I have computed the results. In my data set, the ground truth images, the mask images were already present. But in your case, if it is not present and you need to compare the detected results, you can create using these applications in the MATLAB. Then you can go on export, you can export the images one by one, in which segmentation you need to save mask image, and similarly the image will be saved in your folder. So this was all from my side. If anybody have any query, they may ask. I hope you may get 1-2% of related to image forgery. What is image forgery? How we can implement different methods? How we can use MATLAB? Yes, sir. Python code is available. You can check different, like you can check on GitHub. Different codes are available of CNN, of image forgery. Yeah, it is your flexibility. Sure, sir. I will share the code on. You can contact me through my email ID. I have mentioned in the PPT. I'll share the code.
Ma'am,
Yes, sir.
my question is related to segmentation.
Okay.
Segmentation for deep learning model is mandatory. Is will increase the accuracy for the deep learning model, or we
No,
can.
no, 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 sir. Segmentation is not mandatory, but there are various pre-processing techniques. For example, you can enhance the quality of image. You can apply different histogram algorithms, so that I need to detect forgery images, right? So for detecting the forged images, I need that there can be some enhanced images. Like I have applied Clahe. I will again show the image if it is visible. Uh, Second.
I'm asking related to classification task. Before classification, if
Before, so you are asking before classification, yes, you can apply, but it is not mandatory to apply segmentation. It depends upon your task, that what you want to do.
ma'am, have
Either
you have you did any experiment related to this without segmentation and segmentation? Uh,
Yes, sir. I have written various research papers. Like in one or two research papers, I have not applied segmentation. I have just converted my images into different channels. Like I have used YCBCR channel, and after that, directly I have applied my feature extraction techniques. In some cases, I have applied the segmentation. So depending upon the results, depending upon the applications, it varies.
I'm asking related to same application where once we applied the segmentation and another case we don't apply the segmentation. In that case, the result will be same in DL model especially.
So you can do one thing. You can calculate your results. You can compute your results using segmentation plus your convolutional neural network result. You can do assemble learning. Second, you can apply normal convolution and you can compare your results, which will which will be better technique you can apply. You can implement to your data set.
Okay, thank you.
Oh, okay, sir.
Thank you, ma'am. Assuming that there are not further questions, on behalf of Faculty Development Program on Deep Learning Applications, organizing committee, I thank the respected FTP speaker, Dr. Navneet Kaur, for their valuable talk. Thank you, ma'am.
Okay, thank you so much, Sanjana. Okay, thanks a lot. Thank you, Abhishek sir.
Thank you, ma'am.
And thank you, everyone. I hope the session was useful.
If you have any question, you can ask the question. Session is over. You can leave the session now.